So we'll write a sample program that will allow the user to enter data into a list, and then we could sort the data. Then we're going to run through it and find the highest value and the lowest value, which if you have it sorted is actually pretty easy. So we're kind of at cross purposes there. Maybe we won't sort the data until the very end. And then calculate the sum and the average of it. So it sounds like a lot. It actually is not too bad. So go ahead and open up idle. Whoops. Alrighty. So what kind of numeric data are we tabulating today? We always use, grade scores. Seems like there's other kinds of data out there in the real world, but why don't we do temperatures? So data entry, temperatures. We're going to need a list to represent our temperature data. Temp, or temps. How about that? We're going to create an empty list. Now we also would like perhaps a list of days or a list of weeks or a list of months or something like that to prompt us for what kind of data we are tracking. So let's make a list of days of week. So I'm just going to put day is equal to, but we're going to go ahead and fill this one in. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we have done this before. Write a loop that would print out that array. How would we do that? What's one way of printing out that array? We talked about for each loops and for range loops. How would we do a for range loop? Yeah, let's do, S in range, or I like I for index counter, but whatever. And then what is our range going to be? We want it to be the length of this array, just so that we can print them all out. And then print, oh, that's odd. Print that day. There we go, like that. Doesn't matter what the name of the variable is here, as long as it, conveys some meaning. It's a counter that's going to go from 1 up to but not including 7. Excuse me, it's going to start at 0 and go up to but not including 7. So that's 0, 1, 2, 3, 4, 5, 6. This should just print out all the days. That's good enough. So save this one as temps and let's make sure it works. Right now that's all we wanted to do, is print a list of days. It doesn't because I have bad syntax. I have a missing parentheses here. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So it printed those. So what do we want the program to do? We want it, don't type this, we want it to look like this. What is the temperature for, Monday? And we can type it in. We'll type in 45. What is the temperature for Tuesday? And we'll type in something else. That's the kind of thing that we want to do. So instead of just printing out the day, we need to be using some input statements. But let's go ahead and separate it into two things like we have been doing. It's not going to make it look exactly like that, but let's print out the message. What is the temperature for? And let's print out that day. And then a question mark. That's going to look a little bit weird because the question mark is going to have a space before it, which it doesn't in the English language, but that's okay. Now let's get that temperature. T is equal to input. Convert it to a float. T is equal to float T. And now we need to store that in the array. We need to add it to our list. So now that we have the empty list, that's the list that we want to add it to, temps.append. Append is how you add a piece of data to a list. So there we go. That makes an empty list. I'm just taking some extra notes over here. L.append adds an item to the end of the list. X is equal to L sub 0. What does that do? If we had a list and we appended some items, what does that do? Yeah, it gets the value of the first item. Gets the first item in the list. How do you get the last one? X is equal to L negative 1. Gets the last item in the list. If the list is only one item long, they would be the same thing. Or instead of saying X is equal to, you could just do print. You know, we have been printing. This actually retrieves the value and stores it in a variable for later use. All right, at this point, we should have a program that will get all of the data and put it in a list. Just to see what that list looks like. This isn't a good way of printing a list, but let's just print that list out all in one line in a primitive format to make sure that our program works so far. What is the temperature for Monday? Just type in some numbers. 10, 20, 30, 40, 50, whatever. And there we go. It shows us some numbers. 10, 20, 30, 50, 23. Now we have a list that is the same length as the day list, where each item in the temperatures list matches a day. What is that called when you have two or more lists of the same length where the data is related by the position? Have we used the term parallel list yet? Feel free to shake your head and go, no way. All right, okay. This is what's known as a parallel list. A parallel list is when you have two sets of data, two lists, that are thematically united by their index number. So like we say we have three people. We have a list of names. Don't type this stuff. And then we have a list of ages. Like I said, don't type it. Joe is 23. Beth is 25. Sam is 21. We have three elements. Now, if names was a list all by its lonesome, it would look like this, right? Names is equal to Joe, Beth, and Sam. And the ages list would look like this. And I'm going to take a little bit of care to line them up, even though when you're programming and you're typing stuff in, you don't do this. Right? So how long is the first list? 3 items long. How long is the second list? It's 23. This is element 0 of that list. This is element 0 of that list. That's index 1, index 2, 1, index 2, index 2. So they line up like that. Parallel, kind of like parallel lines in geometry. Parallel lists. Lists of the same length where the data is united by its index number. So when I wanted to print these things out, I would have a counter loop, a for range loop that counted out 0, 1, and 2, and I would print out names sub 0 and ages sub 0. So it would print Joe 23. Then I would print out names sub 1 and ages sub 1. So it would print out Beth and 25. And then names subscript 2 and ages subscript 2. So it would print out Sam and 21. So that's what's known as a parallel list. I'm going to cut these and put these into the notes instead. Is that how you spell parallel? Or let's not say a parallel list. Let's say parallel lists are 2 or more lists of the same length where the elements in each list are linked by their index number. Such as a names list and an ages list. Okay, so that's the notes about parallel lists. What we have here, by the time this for loop is done, are parallel lists. Let's get rid of that stuff. I'm going to just comment it all out with some triple quotes. Where it says print temps, under that or above it, let's print out the day array. I say array because I teach a lot of other classes in which they're called arrays, not lists. This class are called lists. There we go. We have to enter some more temperatures. And that did it. See, Monday was 213 degrees. It was pretty hot. Tuesday was 45 degrees. Wednesday it was 1 degree. Thursday was 2 degrees. The weather's pretty crazy here. Friday it's 35. Saturday it's 45. And Sunday it's 67. So what is the index value of Thursday? Yeah, so that's 0, 1, 2, 3. So the temperature on Thursday is the index value of 3 in this list. 0, 1, 2, 3. So on Thursday it was 2 degrees. And what do you know, it was. All right, we have made our list. We have our data. We can get rid of those two things because we're going to print them in a better format. We're going to use another range loop. For in range, the length of the day list, we could base it on the length of the temp list as well because they're of the same length. Print the day at that value and then the temp at that value. Temps at that value. There's our cute little list of ages and temperatures. Excuse me. Days and temperatures. So now we want to get the sum of the list. If we want to do it easy like, we just use the sum function that they give us. Total is equal to sum of the temps. We could print that out. That's the easy way. That's much too easy, so we're not going to do that. However, do remember this, because in the real world there's no reason to write a for loop to add up all these temperatures. Now we could use another range-based for loop, or we could use a for each loop in order to get all the temperatures out. We haven't done a for each loop yet in this example, so what would that look like? For, and I'm just going to call it T for temperature, in, now I'm not going to use range because it's not a range loop. What do I do here instead? I want to step through all the temperatures, so what am I going to put here? Temps. In order for this loop to work, we need to have a a total variable to add everything into. So total is equal to 0. For T in temperatures, total plus equals T. By the time we're done, now we have the total. So let's calculate the average. Average is equal to total divided by what? If it was 3 temperatures, we would divide it by 3. If it's 8 temperatures, we divide it by 8. The length of the list. And now let's print that out. Print the average temperature was, comma, average. Run it, enter some temperatures, and it should calculate the average. That's the lengthy way to calculate the average. The short way is just to do this. Average is equal to the sum of temps divided by the length of temps. And then you could print it out. We've already printed it out. We don't need to again. But that would calculate it in one line rather than the 4 lines that this took. So why did I show you this? Because I'm just trying to burn into your brain the idea of loops to hit a list. You could do all sorts of things. You could go through the list item by item looking for the maximum value. You could go through the list item by item looking for the minimum value. We already have a max and a min function. I wonder if we could just, let's play with that and see if that works. Just go back to the shell, do run Python shell. In fact, I'm going to close it and start it again so that I have a fresh one to play with. Run Python shell, and I'm going to make a list that just contains 3 numbers. L is equal to 8, 6, 7. What is the max of that list? Let's see if it'll tell us. 8. What is the min of that list? 6. Very good. What is the sum of that list? 8 plus 6 plus 7. So those built-in functions are pretty useful, meaning that we don't have to write loops that will process the entire list and look for them. Yes, sir.
It says age is not specified. Where do we put in for age?
Age isn't part of the assignment. I said not to type that in. Those were just notes that I'm pasting into.
Oh, just the name?
We're not doing anything with names either. Let me bring the code back up. This is all about temperatures. Everything that had to do with ages and stuff like that, you can comment out with putting 3 quotes up at the top, or you can cut it out and put it in another file. It's not part of this program. I swear I already had this open. There we go. So we know how to access every element in a list. That's a for each loop. For H in horseman, print H. It would print out war, famine, pestilence, death. If you want to get the length of the list, you do it with the len function. This is a for range loop. For I in range, the length of the horseman list, print out horseman I. I guarantee that if I ask somebody to do that and then that, somebody's going to mix them up. Try real hard to remember the difference between them.
And I is just a variable.
It's just a counter variable, right. You could call it Woody, and you could call this one Buzz. And for Buzz and horseman print Buzz, it would still print out war, famine, pestilence, and death. So we're going to call this one a for each loop. And this one, we're going to call this a for range loop. List membership. If you want to see if a value is in another list, you use the in keyword. Go back to your shell. If you can't find it, just do shell. Or, if you're in the other one, do run, start new shell. Run Python shell. Okay, make a list. Just make it contain 3 numbers, just like we had here, 100, 200, 300. And then let's find out if the number 150 is in that list. 150 in L. No, it is not. So you would word that in your code as something like, if 150 in L do something. Print yes. Then backspace over it. It's not going to print yes because 150 is not in that list. If we do the same thing, 100 in L, it's going to say true because it is. So if we do if 100 in L colon, print yes, and then on the next line backspace all the way back and hit enter, it's going to print yes because 100 was in it. So let's say we want to find out if war is in the horseman. If war in horseman, print yes, war is there, whatever. What if you wanted to find not only that war was in there, but what its position was? You can do that as well. I'm going back to the shell, l.find 200. Didn't work. So we'll skip that for a moment. index. That's what it's called. Okay, so if I want to figure out what the position of 200 in my list, if you remember my list was 100, 200, 300, it is L dot index of 200. We can use that information. Say we want to find out what the hottest day was in our program. So we're going to go back to our program. We're going to find out what the hottest day was. To do that, we need to find out, one, the value, the highest value, the highest temp, and then the index of that temp, and then we need to use that to print the day. Use that index to print the day. So we're going to do those three things. We talked about a function that'll get the largest value in a list. What was it called? Max. Yeah. So I'm going to make a variable called highest is equal to the max of the temps. But now we need to find out where that is in the list. It might be at the beginning of the list. It might be at the end of the list. We don't really know. But we want to be able to print out which day it was. So index is equal, I'm not liking index. High day is equal to temps dot index of the highest temperature. And then let's print out that day. Print day at that high day. Let's put some extra text in there though. Comma was the hottest day. So I ran it. I typed in 1, 2, 3, 4, 5, 6, and 20. Obviously, the highest temperature was, well, it doesn't even say, but it says Sunday was the hottest day. Which is true. Using the concept behind these 3 lines, write 3 more that'll figure out the coldest day. Figure out the coldest temperature, get the cold day, and then print out the coldest day. So the coldest is equal to the minimum temps. The coldest day is equal to temps dot index of the coldest temperature. And we want to print the day of the cold day. Comma. Was the coldest day. Okay, we're going to keep going through that chapter a little bit more, but this is pretty much the end of the useful part of this program. And what do I mean by that? Now we may throw some things in that may sort the days or whatever, but once you sort the days, we've kind of broken the connection. If we sorted the days so that they were in alphabetical order, no longer is it a parallel array because element 0 doesn't match element 0 of the temperature array. We scrambled one of them. So not real useful. So I'm just going to put a row of dashes here, meaning that's the end of the useful stuff. So if you want to sort the array, there's another function, kind of like min and max, called sorted. So if you declare an array like that and then you call sorted, it returns a sorted version of it. So we could sort our days. It doesn't do anything useful, but day is equal to sorted day. Temps is equal to sorted temps. Now let's print those back out. For n in range of the length of the days, print day sub n, subscript n, temps subscript n. We will see that the data is indeed sorted. It's no longer a parallel array. The data will not match what we typed in earlier. So is this sorted? F is before M is before SA is before SU is before TH. Okay, so those are indeed sorted. The values are sorted, 1, 1, 1, 2, 2, 2, 5, you know, like that. It's just broken because Monday was 5 and there it's not 5, you know. But if you do want to sort your data for some reason, you can do that. One reason you might want to sort it is it makes it really easy to find the highest value. It's the last item in the list. Or if you want to find the lowest value, it's the first item in the list. But since we have min and max, that doesn't really matter that much. But, you know, if you have a list of names, you might want to print the names in alphabetical order. So in that case, you might want to do sorted. So, in these examples that I've been typing in from the code, if we wanted to sort the horsemen, we would do horseman is equal to sorted horseman. And then when we printed them out, they would be in the order death first, famine, pestilence, and then war. If you want to remove an element from the list, you can do that. You specify its index value. Say we don't like the first elements in our list for whatever reason. Day, no, delete. Am I doing that right? Nope, mylist.remove. That's what it is. So, mylist.remove, what? It's not called mylist, it's called day. Day.remove, we're going to remove the first item from the list. And then temps.remove, we're going to remove the first item from that list. Now let's just print them out. Print day, print temps. And we'll see that that did remove the first element of each list. As a matter of fact, it broke up. It broke. Where did I get X? It's looking for the value. It's trying to remove. I did that wrong. My apologies. Forget what I said about remove at this point. We will get back to that. What it's actually trying to do is remove an element by that value, not by that index. What do I mean by that? If you had this, names is equal to Jeff, Joe, and Jill, and then you did this, n.remove Joe, then when you printed it out, it would say Jeff and Jill. What's the length of that list once we've removed Joe? Yeah, 2, because it had 3 elements, now it's got 2. So you can write a function that makes a list. All you have to do is create the list in the function and then return it. Let's play with that. DEF make nums. It's going to make a list of numbers. The numbers are just going to be, 10, 20, 30, or something like that. We'll come up with something. So we need to make an empty list to add stuff to it. I want to make my empty list called R, because I'm going to be returning it. Or no, nums. Nums is equal to, I want it to be an empty list, so what do I type? Yeah, the empty brackets. Now I want to count from 10 up to 100, skipping tens every time. So for x in range, starting at 10, going to 1 past 100 so that it'll actually stop at 100, but increment by 10 each time. And then nums plus equals x. And then return x. So down here, if we want to store those in a value, we could do L is equal to make nums. And then we could print L, and it's going to print a list that contains the numbers 10, 20, 30, 40, etc. Now this business about having to enter 7 temperatures each time is getting a bit tedious. So we should probably switch over to a second file. Take those lines that make nums all the way down to print L, cut those and do a new file. Save as, call it April 6. Paste them and then let's run them. Whoa, what do you know about that? That's not how you add anything to a list. That's how you create a sum or a total. What is the function named that adds something to a list? Let's go back and look to see how we did it in the other one. All right, the code that added it to the list, to our temperature list, is in here. What function there was the one that added it to our temps list? Append, right. We're going to do that to our nums list. So nums.append x. And it only printed 100. That is certainly not what I was expecting. Because I returned x rather than nums, I am not paying attention. There we go. Okay. The changes we made. This needed to be nums.append x, and that one needed to be return nums, not return x. Now it will work. And there's our list of those numbers. So this function, write a function that returns a list containing the numbers 10 through 100, skipping by 10. That's how we did that. Write another make nums. Call it make nums 2. That does this. Write a function that returns a list containing the numbers between 20 and 30, skipping by 1. So you're going to need that definition. And then you're going to need to actually call it to test it. So down at the bottom, after your return, you're going to need to do L is equal to make, whoops, I wanted to call that make nums 2. Sorry. L is equal to make nums 2, and then print L. So here's what you need to fill in. A function that returns a list containing the numbers between 20 and 30, skipping by 1. Fill in here. Copy all that, paste it here. But if I wanted to start at 20 and end at 30, what should I make these two numbers?
20, 31.
Yep, 20 and 31. If I wanted to skip by ones, I could put a comma 1 there. But if you're going by ones, you can also leave that off entirely. So that's totally cool, or you could leave it off. Either way would work. Pardon me? Yeah. We'll want to upload them both. Do you need the Dropbox right now, or?
Yeah.
Okay, let me do that. Write a program that asks for the rainfall for a series of months. You know, what is the rainfall for January? What is the rainfall, you know, etc. Put all of those rainfall measurements in a list named rain. Print the data, the month, and the rain for that month. Print the average rainfall and the month with the lowest rainfall and the month with the highest rainfall. That ought to sound real familiar because that's exactly what we did with the days, right? I didn't hear a resounding right, but that's pretty much the exact same thing that we've just done. If you have a string, you can split it into a list really easily. Go back and do run Python shell. Make a list of colors. Colors is equal to red, green. No. We're just going to make a string. Sorry, my mistake. Red, green, blue, yellow, orange. Now we want to get a list of that. So, C, which is going to be our color list, is equal to colors.split. and then hit C, and it'll print out red, green, blue, yellow, and orange. So that was a quick, I'll be right back there. That was a quick way of turning a string into a list of values. So if you're going to be opening a document and scanning for words, that might be something you want to do. Read in the entire document and then make a list that has all the words in that document. So let's go back to that April 6th script we were working on. Let's ask the user to type in a sentence, and then we're just going to break it up into strings, into a list of strings. So I'm going to say text is equal to input, please type a sentence. And then words is equal to text.split, like that. And then let's print the words out, like that. Hello there, my good friend. I typed in hello there, my good friend, and it printed out a list. Hello there, my good friend. I don't think we're going to do much with split. Last time we did Simon Says in the previous semester, we used split so that we could pass in all the commands like this. You remember our Simon Says? We had, don't type this. We had commands, and then we listed some stuff like up, forward 30, right 90, forward 90. We had all that right, except they were broken up like this. That's what our program looked like. With split, we could modify it so that it just looked like this. Commands is equal to forward 30, right 90, forward 90, that kind of thing. And then you use the split function to turn it into a list. If you still have, let's not, you've got the idea. You can turn a string like that into a list like that pretty easily. So if I have those commands, and again, don't necessarily type them, we've already done split right here. If I had those commands there and then I wanted to turn that into a list, I would do commands is equals commands.split. And when I was done, commands would now look like that rather than that. I'll just put that in our notepad. Alrighty, so vocabulary. We haven't talked much about cloning. We haven't talked about much about aliases. I guess it's worth mentioning. Let's go back here and make one list that's a list of colors. C is equal to red, blue, green. And let's make another list that's the same list. C2 is equal to C. Now we're going to remove red from that list. So C dot remove red. And now we're going to print C2. And what do you expect C2 to contain? We removed it from C, right? So it ought to still be red, blue, green, but it's not. When we run it, it just says blue-green. And the reason why is that doesn't copy the contents of the list. It just points two of them to the same list. It's called an alias. You know, Clark Kent is an alias of Superman, but they're the same person. You dye Superman's hair green, and Clark Kent's going to show up at work with his hair green. So they're the same thing. C2 and C are the same thing. So if we change C, it changes C2, and if we change C2, it changes C. So C2 is an alias of C, just like Clark Kent is an alias of Superman. They're the same thing. If you want a list, if you want to make an actual copy of the list so you can do other things with it, you use a funny form of the slice syntax. Up here, let's add some comments. C2 is equal to C. We're just going to say C2 is an alias of C. But underneath that, we're going to make a copy of it. C3 is equal to C. We want to do a slice. Like that. Looks goofy. C3 is a clone copy of C. Why does it do that? Well, if you leave the first number off in a slice, what does it assume? It assumes a 0 there. And if you leave the last number off, what does it assume? The end of the list. So that just assumes the whole dang list. So now that we've printed out C2, let's also print out C3 down here. Print C3. And we will see that although C2 has an item removed from it, C3 is a copy of the original list. So when red got deleted from it, it was not removed from C3. So that's what an alias is. It's when you have multiple variables that point to the same object, the same list. Now that's not true of variables. If you say x is equal to 3 and then y is equal to x, then later on if you say x is equal to 10, well y is still equal to 3. But if it's an object, if it's not a primitive variable like a number, then you can make aliases of them. To clone is to make a new object that actually has a content of the entire list. An element is one of the items in the list. How do you select which element you want to get? Use the bracket operators, the square braces. The position in the list is called the index. If you're going through a list, it's called traversing the list. That's a fancy word. I'm probably not going to ask you to define traversing. It just means starting at the beginning and going to the end. And we've shown two different ways of doing that, the for each loop and the for range loop. And the step size. The step size is the value in the range statement that says whether you're counting by ones or tens or hundreds or whatever. If you leave it off, it assumes a step size of 1. So let's look at this one. What would this list contain? It's going to start at 10, right? Then what are the values that are going to it will contain after that? 10 and then minus 2. So what's the next one? 8, 6, 4, 2. Is it going to include 0 or not? It's not, because this one always has to be one past the final value. So if we wanted it to go 10, 8, 6, 4, 2, 0, this would actually have to be a -1. And again, I apologize for Python's weirdness in that case. Just like if it was so that would be 10, 8, 6, 4, 2. If we wanted it to go down to 0, what change did I have to make to it? Yeah, I changed that one to a -1 so that it would count 10, 8, 6, 4, 2, and 0. What if I swap these numbers? What if I made it 0 to 10 by positive 2's? What's the first number it's going to print? A 0. What's the last number it's going to print? Are we all clear on why it's going to be 8? Hope so. 0, 2, 4, 6, 8. If we leave off that 2, what would the last number be? So right now it just says that. The last number, and I think I already heard you say it, it's going to be 9. Right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you're starting at 0, you don't have to put that first number there. It is assumed. So that would be the same as doing this. Same thing. Just like this would be this. Nope. If you're going to specify a step size, you have to have all 3 parameters. We had like 5 people leave. What's going on? All right, the last thing I want to do, we have a short little bit of time left, is to show that you can make lists that are not only numbers or strings or whatever, but lists can be absolutely everything. So we're going to make an entire gang of turtles. Let's define the colors that the turtle will be. Colors is equal to red, green, I forgot to put the brackets around it. Red, green, blue, orange. So we're going to have 4 turtles on the screen. So import turtle, lowercase t. T is equal to turtle dot uppercase T turtle, parentheses in parentheses. Now let's make 4 turtles. If I wanted to make a for loop that would just count 4 numbers, what would that loop look like? For, just say I wanted to print the numbers 0, 1, 2, and 3. What would that loop look like? Yeah, we need some variable, doesn't matter what it's called, x, and then what comes next? For x in range, and I want it to go 0 up to 3. So I could do 0, 4, or I could just do 4. Either way works. Now I did not actually mean to do t is equal to turtle there. Take that. We're going to modify our code a little bit. Cut that line for now. Turtles is equal to empty list. We're making an empty list of turtles. Let's call it gang instead of turtles because it's easier to type gang. So inside that for loop, t is equal to turtle dot turtle with a capital T, parentheses, and let's append that to our gang of turtles. We want to set each turtle to a different color. So, for X in range 4, T.color CX. So the first turtle is going to be red, the second one's going to be green, the third one's going to be blue, and the fourth one's going to be orange. And we want each one to start off in a different direction. So T.left X times 90. All right, now let's give some commands to them. I think we can shorten the syntax to use not a range, but the for each loop. For T in gang, T dot forward, let's make them all go forward, 90 pixels. And then for T in gang, colon, let's make them draw a circle, 45 pixels. Save it, call it gang.py, run it. Hope it does something. Can't say that it is. Did very little. Huh. That was underwhelming. Well, there they go. Okay, that last, these with the gang statements, those T in gang did not seem to work much. I apologize, but there's several mistakes I need to fix here. We could just do this. T is equal to gang at element X. Let's try that one. This is the line that I just changed. All right, that worked. So we have 4 different turtles. They're all on the list. To step through them, it's as easy as using a for each loop. This goes all the way through our list of turtles, telling each one of them to go forward 90. This one goes all the way through our list of turtles, telling each one of them to draw a circle of 45. This syntax was a little bit more complicated because I used a range, but I didn't have to do that. I think I want to go back and modify it to look just like this one. No, I don't, because I liked having that number so that I could set one going at 0, one going at 45, or 90, one going at 180. But we could instead make a list of starting directions. That'd be the last change we make to this program. So this code right here is going to be radically changed. So I'm just going to comment that out for now. Here we want to make some directions, some starting directions. The red turtle is going to start at 0. The green turtle is going to start at 90 degrees. The blue one's going to start at 180. And the orange turtle is going to start at 270. So now I'm not going to use a range statement because this syntax is so much cleaner. I'm going to delete those lines. for every turtle in the gang, for T in gang, T.color, whoops, see there, I still don't have my, my X variable. So that was a failed effort. That didn't work. I'm going to undo that cut that I made. And if I undo the cut that I made, then that direction really doesn't help any. Just change that C times 90 to D sub X. And I guess we're done there. I can't think of a better way to do that. So a list can be a list of anything. A list could be a list of lists. It could be a list of turtles. It could be a list of strings. It could be a list of lists of strings, you know. So you can stick anything that you want to in a list, but if you don't know what's in the list, it's going to be a problem. We could be goofy and do something like this. Make a new list, and you don't necessarily need to do this. L is equal to, okay, now I'm going to append my favorite number to it. Then I'm going to append, you know, a string to it. Then I'm going to append a new turtle to it. Great. Now what am I supposed to do with all that information? How would I know how to process it? So in general, your lists are probably going to need to be all of the same kind of data for you to understand what to do with them. If you can think of a way to get around that, that's great. In some other programming languages, the lists all have to be of the same data type. They all have to be integers, or they all have to be floats, or they all have to be strings. Python's more flexible than that, but here we've made a list that has an integer, a string, and a turtle. Let's print out that list. I said you didn't have to do this, but I'm going to see what that does. Well, that certainly didn't work. Sorry. Turtle.turtle. Oh, fine. Get rid of that new keyword. That's Java. All right, so here's our list. L is equal to 1, 2, 3, hi, and then turtle.turtle object at blah, blah, blah. How would you know what you were dealing with if you were trying, you know, if you were manipulating that data? All right, gang. Let's call this one done. Go ahead and upload it into the Dropbox. I think I've kept you here slightly too long, which I apologize, especially with me coming in late. So go ahead and upload what you can to the Dropbox. I'll upload the homework assignment, and I will see y'all on Tuesday. I'll come look just a sec.
You said all three of these lists?
Yeah, go ahead and just drop them all three in.